In today's question, two cars A and B are moving away from each other in opposite directions. Both cars are moving with a speed of 20 meters per second with respect to ground. If an observer in car A detects a frequency 2000 Hz of the sound coming from car B, what is the natural frequency of the sound source in the car B? The speed of the sound in the air is given as 340 meters per second. So in this case, we have both, you can see the source as well as the observer moving away from each other. So you can say if this is car A and this is our car B. Car B is our source and car A is our observer. And both are moving opposite to each other with the velocity of 20 meters per second, which is same for both the cases. And we have to find out that the actual frequency of the natural frequency of the sound source B. So in this case, we are going to make use of rather, you can say, Doppler effect equation. So we start from there. Doppler effect equation, and this gives us that f prime will be equal to f plus v naught, v plus v naught, and v plus vs. Here f prime is our observed frequency by car A. You can say f prime is the frequency observed by car A, and that is our 2000 Hz. And f is the natural frequency of the sound in car B. F is the natural frequency of sound in car B, and this we are supposed to find out. V is the velocity of the sound in the air, which is given to us. Velocity of sound, that is given as 340 meters per second, and v naught is the velocity of the observer, or we can say speed of observer, which is car A. V naught is the speed of observer, which is our car A, relative to the medium, relative to the medium, and this is given as 20 meters per second, and the direction is given as moving away. And we have Vs is speed of the source, which is our car B, relative to the medium, and the speed is given as 20 meters per second, and its direction is also moving away. moving away. Now we are going to adjust this equation, let us call this equation number 1, according to their relative motion. Okay. So we say adjusting equation 1 for relative motion. Adjusting equation 1 for relative motion. So since observer, that is car A, and the source, that is car B, are moving away from each other, so since observer, that is our car A, and source, that is our car B, car B is moving away from each other, are moving away from each other. Therefore, we can write that our f prime will be equal to f, and this becomes v minus v naught and v plus vs. So from this equation, we can draw an important conclusion that the observed frequency will be lower than the natural frequency. You can say observed frequency will be lower than natural frequency. Natural frequency. And we are supposed to find out the natural frequency f. So we can modify the equation. We can say our f will be equal to f prime v plus vs divided by v minus v naught. We substitute the value. F prime is given as 2000, and we this have 340 plus 20 and divided by 340, and we have minus 20 because they are moving with same velocity. So this gives us that our f will be equal to 2000 multiplied by, this will be coming as 360 divided by 320. So approximately it will be equal to 2250 hertz. So this is the natural frequency of car B. This is the natural frequency of sound of car B. And the options that are given to us, we can say option number B is the correct option. Option B is correct. This completes the question. Thank you.